Hey, today we're talking about section 4.3, part 2, and we're talking about trig identities. So if we're talking about 6 reciprocal identities, I know that sine theta is equivalent to 1 over cosecant theta. That cosine theta is equal to 1 over secant theta. Remember, S goes with C and C goes with S, never together, meaning sine and cosecant are reciprocals and cosine and secant are reciprocals. Tangent is equivalent to 1 over cotangent. Cosecant, so we're kind of repeating here, cosecant is the reciprocal of 1 over sine. Secant, remember we're talking about this again, secant right here is the reciprocal of cosine. And lastly, talking about cotangent is the reciprocal of tangent. 2 quotient identities, we know one of them, when we've been using it a lot, is that tangent theta, in addition to it being a reciprocal of cotangent, tangent is also the value of sine theta divided by cosine theta. And thus, it's a reciprocal function. Cotangent is the reciprocal of also tangent, which can also be written as cosine over sine. And then the new thing that we haven't really talked about yet are these Pythagorean identities. Keep in mind that Pythagorean theorem says a squared plus b squared equals c squared. The Pythagorean identity says this. The first one is sine squared theta plus the cosine squared of theta equals 1. And let me show you why, okay? And this is because if x equals the cosine of theta, like we've been talking about, and y equals the sine of theta, like we've been talking about, and we're talking about a circle here. In this circle, we know the equation of a circle is x squared plus y squared equals r squared, or 1, because our radius is 1. If we use this idea of x equals cosine theta and y equals sine theta, I can say x is really cosine squared and y is really sine theta squared equals 1. So this idea that this is our Pythagorean identity, sine squared plus cosine squared, comes from there. We have 2 others that we can derive. If I just simply take our cosine, if I take our cosine squared theta and I simply divide everything by cosine squared, then I know cosine squared divided by cosine squared is 1. Sine squared over cosine squared, well, because our trig function, which is equivalent to sine over cosine, is tangent. So sine squared over cosine squared is tangent squared, and 1 over cosine, look at our 1 over cosine is equivalent to secant. So 1 over cosine squared is secant squared theta. So that's one of our other Pythagorean identities, 1 plus tangent squared theta equals secant squared theta. And then our other one can also be derived from cosine squared theta plus sine squared theta equals 1. If I divide both of them, instead of cosine squared this time, if I divide everything by sine squared theta, I get cosine over sine is really, well, it's right here, cotangent. So cotangent squared theta, sine over itself, sine squared over sine squared is 1, equals 1 over sine is really cosecant. So that's our other Pythagorean identity, that cotangent squared theta plus 1 equals cosecant squared theta. Okay, and then really quickly, if we're talking about applications involving right triangles, what does it mean to solve a right triangle? So if we're talking about the angle of elevation, the angle of elevation goes upward. So if I'm looking at this angle here, an angle of elevation goes from the base, that 0 degree angle, upward to whatever the angle is. An angle of depression basically means that we're going downward. That from this 0 degree angle, our angle goes downward here. That's our angle of depression. And that's all we've got for today. I'll see you back in class.